Hi everyone, welcome back to my channel, Numerics with Nadia. In today's video, we're going to learn about algebraic expressions. We're going to learn what they are, how to simplify them, a few different terms, and we're going to practice combining like terms. If you guys haven't watched the last two videos I've posted, the one on the introduction to the distributive property, as well as the distributive property with the algebra-based examples, I would highly recommend watching those first prior to this video. But for today's lesson, we're first going to start off and we're going to go over what is an algebraic expression. Then we're going to go over and we're going to explain what is a variable, and we're also going to explain the difference between a constant and a coefficient. And then last but not least, we're going to do some practice. Our practice section for today is going to be split into two parts. For the first part, we're going to practice identifying terms. And then for part two, we're going to practice combining like terms. But before we get into all of that, we first need to understand what is an algebraic expression. An algebraic expression is an expression that may contain numbers, operations, and one or more symbols. Parts of an algebraic expression are called terms. So we have two vocab words in this definition. Obviously, we have algebraic expression, but we also have term. And what I'm going to do now is I'm going to write out an example, and I'm going to color code all of the different components of the algebraic expression, just so we can visually understand things a little bit better. So now that I've highlighted our two vocab words that we have so far, I'm going to write out our example. Our example for today is going to be 5x plus 6. So I've color coded them separately. The 5 is in red, and that's because that stands for one of our new vocab terms as well. So the 5 here is the numerical factor of a term that contains a variable, and it's what we would call a coefficient. So here our x is a variable, and the number that goes in front of that variable is always called our coefficient. So that's what our 5 represents in red. Now we'll move on to x, which we've already kind of gone over. It's our variable. But what is a variable? What does that mean? The symbol that represents one or more numbers is what we would call a variable. So a variable most of the time is just a letter, any letter of the alphabet. Here it's x. X will be the most common variable that you guys will see, but it can be any other letter as well. So now that we've defined what a coefficient is, what a variable is, now we'll get into our last term for today. Looking at the 6, a term without a variable is called a constant, right? 6 is just a number and doesn't have anything attached to it. So 6 is our constant. I would highly, highly recommend you guys copy this whole thing into your notebook because it's very, very useful. We'll be using it in our practice questions. You'll be having to know and be familiar with these terms from here on out in algebra, geometry, pre-calc, any other math class you take. So definitely copy these down into your notebook. And now we will get into our practice section for today. For part 1 of our practice section, the directions say to identify the terms, coefficients, and constants in each expression. So these are all the terms that we've already defined. So using that notes that you took down from the last slide, we'll use that in our practice now. So for number 1, our first example, we have 12 plus 10c. So first we're going to write out our terms, then we're going to write out our coefficients and constants for each one of these expressions. So our terms here are just what makes up our algebraic expression, which is the whole thing, right? It's 12 plus 10c, that is our algebraic expression. Those are the terms in it. Now looking for our coefficient, the coefficient is the number in front of our variable. Here our variable is c. So our coefficient would be 10. Our constant is just the number that does not have any other term associated with it. And our constant in this example is 12. Now it's possible to not have a constant. We'll see other examples with that as well. But for now, we'll move on to number 2. For number 2, we have 3m squared plus m plus 6. So again, we're going to write out our terms, our coefficients, and our constant. Our terms is just the entire algebraic expression, which is 3m squared plus m plus 6. We have two types of variables here. We have m squared and m. They are not the same. So our coefficients, we have 3. That's in front of our m squared. And what's in front of our m? It's just a 1, right? We have 1m. We don't necessarily write that coefficient out, but it is there. So our coefficients are 3 and 1. And then when we look at our terms, the only term left is our constant, and 6 would be our constant. So now that we've wrapped up number 2, let's move on to our third example. For number 3, we have 5c squared plus 7d. Again, terms, coefficient, constant. Our terms are 5c squared plus 7d. Excuse the typo here. Now when we look at our coefficients, it's the numbers in front of our variables. So our coefficients are 5 and 7, and there is no constant here, and that's okay. And that wraps up our third example for today. Our variables are c squared and d. Again, sorry for the typo there. Now we'll move on to our last example for part 1 of our practice section. For number 4, we have 2m squared plus 15 plus 3p squared. Now again, same steps. We're going to identify our terms, our coefficients, and our constants. Our terms here are just the full algebraic expression, which in our case for number 4 is 2m squared plus 15 plus 3p squared. Now for our variables, we have m squared and p squared. So when we want to find our coefficients, we're going to look for the number in front of those variables. There is a 2 in front of our m squared and a 3 in front of our p squared, so our coefficients would be 2 and 3. That 15 that's left over in our terms, that is what we would call our constant. And as I've already mentioned, our variables are m squared and p squared. So that wraps up part 1 of our practice section for today. Now we'll get into part 2. For part 2, the directions say to simplify the following algebraic expressions using combining like terms. And what is a like term? A like term is two terms that are alike, whether it be that they have the same exact variable or that they are two constants that could be added or subtracted together. That's how we will be combining things. So we'll see this in our examples. Looking at number 1, we have 6k plus 2 minus 4k. Now we have two terms here with the same variable, 6k and 4k. So I will rearrange this and put them next to each other so we can combine them. When we do 6k minus 4k, all we're looking at is its coefficient. So we'll look at the 6 and the 4. 6 minus 4, that gives us 2. So 6k minus 4k gives us 2k, and then the constant just comes along. So the answer for number 1 would be 2k plus 2. For number 2, our algebraic expression is 7n plus 9 minus 3 minus 9n. So we have two constants here and two variables with n's, right? So we'll put those together and our constants together. The 7n minus 9, when we do that, we do 7 minus 9. That gives us negative 2. The n comes along. So we get negative 2n. And now we'll go to our constants. 9 minus 3 just gives us 6. So our answer for number 2 will be negative 2n plus 6. And now we'll move on to number 3. For number 3, we have 2x plus 3y minus 4x plus 5y. So we have two different types of variables here, our x's and our y's. So we'll rearrange this and group those together. When we do that, we get 2x minus 4x. Again, we're just going to be subtracting our coefficients. 2 minus 4 gives us negative 2, so 2x minus 4x gives us negative 2x. Now we'll move on to our y terms. 3y plus 5y, we'll just add the 3 and the 5 together. When we do that, we get 8. So our answer for number 3 will be negative 2x plus 8y. And now we'll move on to our final practice problem for today. For number 4, we have negative x minus 3y plus 4x minus 9y plus 2. Now this one looks the most challenging, right? So many terms to deal with, but we have two terms with x's, two terms with y's, and one constant. So let's rearrange and group everything together. If I put my x's together, I get negative x plus 4x. When I add those together, negative 1 plus 4, well, that just gives us 3. So 3x would be our x term. Now we're looking at our y's. We have 3y minus 9y. 3 minus 9 gives us negative 6. So it would be 3x minus negative 6y, and the 2 comes down with us. We know that the double negative just gives us a positive, right? Or we add. So our final answer for number 4 would be 3x plus 6y plus 2. And that wraps up our lesson for today. I hope you guys enjoyed this video. I know it was a long one. If you did enjoy it and if you did like it, please like it, share this video with a friend, comment any questions or any other video topics you would like to see down below, and I will see you guys next time.